For the next group of questions, it says to perform the operation. That means add, subtract, multiply, divide, do the composition, do whatever it says, and give the domain. We'll go through each of them and do the solving first, and then we'll go back and consider all the domains. So when I'm adding, f of x is equal to 5x plus g of x is equal to x minus 3. I put parentheses around g of x since it has more than one term. Sometimes those parentheses will make a difference. In this problem, not really so much because distributing a positive doesn't really change anything. So we combine like terms and we get what? 6x minus 3. For number 10, f of x is 5x minus all of g of x, and here those parentheses matter. Without them, you will likely get the wrong answer. We need to distribute that negative, making it 4x plus 3. Subtracting 1x gives 4x, and distributing the negative changes it to a plus 3. Okay. If we have more than one term.
Will it be like the time test where we just have one set of f and g?
There will be two groups of questions. In one group, you'll be given a certain f and g. In the other group, you'll be given another. For number 11, f of x times g of x. Here, those parentheses matter. What do I need to do? So I get 5x squared minus 15x. In division, parentheses are not so necessary because that division bar kind of acts like parentheses. That we want 5x over all of x minus 3. You cannot cancel those x's and just make this into 5 over negative 3. You cannot cancel a portion of a fraction. You can only cancel if every part of the fraction can be canceled. So since that 3 cannot be canceled, you can't cancel any of it. Okay? You cannot just cancel pieces of a fraction. You have to be able to cancel the whole fraction. So that's it. That's done. There's no simplifying that can be done there.
Wait, what about, couldn't you do 4x?
For number 13, this is our composition of functions where we have an inside function and an outside function. We take the outside and write it except for the x. So I'm going to write 5 blank, leaving a blank where the x used to be. And then in that blank goes the inside function, x minus 3. To clean it up, we distribute the 5 and get 5x minus 15. Questions on solving any of those? Then we need to talk about domain. What are the two questions we ask ourselves when we're thinking about domain problems? Division and even roots. When we are doing arithmetic, adding, subtracting, multiplying, dividing, so like numbers 9, 10, 11, and 12, we care about the domain of both originals and the final answer. So we'll look at the original f equation first. In the original f equation, do I have any division or even roots? No. So then our domain is all real. So if there are no problems, that means we can plug in anything we want. In the original g equation, is there division or even roots? So that has no problems. So then we need to consider our answers and see if the answers have any problems. In number 9, are there any problems? No. In number 10, are there any problems? In number 11, are there any problems? Do we have division? Do we have even roots? Even roots. We have an even power, right? Squared, but squared is not an issue. It's a square root that is an issue. Okay, so square roots are problems. A squaring is not a problem. So that is okay. In number 12, do we have any problems? Yes. What kind of a problem do we have? Division. So what is x not allowed to be? 3. If x is 3, we would be dividing by 0, and that is the problem. It's not that x can't ever be 0, it's that we can't divide by 0. So it's that whatever that whole bottom of the fraction is can't be 0. So we think about what would I plug in that would make that be 0, and the 3 here would make us divide by 0. In composition, we care only about the domain of the original inside, which was G, had no problems, and the answer. We don't care about the original outside. Does the answer in 13 have any domain problems? No. Okay, so something that did not come up in any of these was even roots. But we've talked about it. It could come up, so let's remind ourselves how that works. An even root is like a square root, except it doesn't always look like a root. What else can an even root look like? A fraction exponent. So like x to the 1/2. X to the 1/2 is really a square root of x, right? Because the bottom of a fraction exponent is a root. What is the domain of x to the 1/2, or the square root of x? What kind of things can we not plug into a square root? Negatives would give us imaginary numbers. So we cannot take square roots of negative numbers. So what will that look like for a domain? Greater than or equal to 0. Square root of 0 is fine, that's just 0. Square root of positives are fine, so we can go greater than. But square root of negatives, that gives us imaginary answers. So if you have an even root, our domain would be x is greater than or equal to 0. Okay?
What's the odd root?
An odd root would be like a 1/3 power.
Well,
So it'd be like a cube root.
what would the domain be?
That would be all reals.
Okay.
Odd roots have no problem. I can take a cube root of a negative number like we did in question number 1. Okay. Questions about domain? If you want more practice with any of these types of problems, these were lesson 7.3. Inverse. To find an inverse of an equation, what do we do first? Switch the y and x. What if there's no y in the question? F of x means the same thing as y, so this becomes x equals y plus 5. And then what do we do? Solve for y. So subtract 5 from both sides, and I get x minus 5 equals y, but technically, if we're going to be notationally correct here, since there were no y's in the original question, we need f of x, but it's not really f of x, it's the inverse of f of x. Now, am I going to mark you wrong if you don't put the proper notation? Probably not, but I would like you to really try.
Does the negative one have to go on the x?
It does. Yep, the negative one goes on the f, not on the x. Yeah, if we called it y, we would also do that inverse thing as well. Swap the variables. Then what do I do first to try to get y alone again? Subtract 3 from both sides. And how do I get rid of that 1/3? I could multiply everything by 3. I could divide everything by 1/3, but dividing by a fraction is kind of tricky. So we're going to multiply everything by 3. Everything. Not just bits and pieces, but every part of this by 3. So that becomes 3x minus 9. A lot of students forget to multiply that part. And if you left it here and put a box around it, I'd probably not take anything off. But we should really change it back to the proper notation. Okay. For number 16, swap out our x and y. What do we do first?
-4.
Subtract the 4. And then? Divide by 2 and divide everything by 2. So we get x over 2 minus 2 equals our inverse function. Yes. 1/2 x would be fine. Yep, that's the same thing as x over. And for number 7, we're going to swap our x and y. What do I do first to solve? Subtract 3. And then take a square root. Now, what do we need to be careful of with square roots? A plus and minus, positive and negative answer. Do we need a plus and minus here? Why not? Okay, in the original question, we're given this little piece of information that says x is greater than or equal to 0. But if we're swapping x and y's, that means that y is greater than or equal to 0, which means we're just dealing with positive answers. So we don't need the plus and minus. What if it said less than or equal to 0? Then we need to put the negative in front of that square root.
If we have square root of x and this is square root of 3.
No, you actually cannot split a square root to take both parts. The square root of x minus 3 is not the same thing as the square root of x minus the square root of 3. Can kind of prove it to you with numbers. If I did the square root of 25 minus 16, that's the square root of 9, which is 3, right? But if I do square root of 25 minus square root of 16, I get 5 minus 4, which is 1. Okay, so it actually doesn't work to split square roots. They have to be together. Good question, because a lot of people did that on the homework. If you want more practice with inverses, that was lesson 7-4.